Okay, so just a few, I guess, administrative things. So you should have all received an email from me, grade report, score on your midterm exam, and also your, I guess, a progress report, how you're doing in the class overall, including your homework and quiz scores. Okay. If you did not get that email from me, then that means there was probably a problem with the email address that you provided me. So let me know, and I'll try to send you an email. So the midterm exams, some of you guys did very well. Some of you did as I expected, and then a few of you did quite poorly. I don't know how else to say it, but so that's always a little bit worrisome for me. So I hope that if things are confusing or you are having trouble understanding things, that you get the help or assistance that you need with learning the material. Okay, so I'm always available during office hours if you have questions, and I, post those videos of the answers to help you out, and I encourage you to practice the homework and make sure you really understand the questions that are asked in the homework. Some of you guys are already worrying about the final exam. I would say don't worry about it yet, but the final exam is cumulative, but it will be heavily focused on stuff from after the midterm. So stuff from today forward will cover about 80% of the final exam. Stuff from before the midterm covers maybe about 20%. The stuff from before the midterm will all be conceptual questions with no calculations involved. So you don't have to worry about calculating probabilities or things like that for the stuff from before the midterm. But you do need to be familiar with the concepts being covered. So, for example, I might ask, I'm not sure, the width of the box in a box plot represents what measure of spread? And you would answer
Q3, Q1.
median. You would answer the IQR. The width of the box is the distance from Q3 to Q1. So the, I'm sorry? Q3 represents the 75th percentile, but Q1 is the 25th percentile. So Q3 minus Q1 is the IQR. So these are all just conceptual questions, testing your understanding of stuff from prior to the midterm. Okay? I guess any feedback before we go on?
Wait,
Yes.
I have a question again. So you said after, so before the midterm, 20%.
About 20%.
And then after everything that we learn moving forward from the midterm.
Right, so stuff that I'm covering from today until the last week prior to the midterm, that will cover about 80%. Yes.
Previous friend they got email before the test saying what you need to get in order, like it's on the final. Do you still do that?
Yes, I plan on doing that. So it'll be similar to this progress report. I'll show a progress report prior to the final exam that says if you want a C, you need to score 55% on the final. If you want an A, you need to score 92% on the final, or something like that. Okay? And that's how that goes. Okay. Yes?
You dropped the lowest quiz, right?
Yes, you take 4 quizzes and I will drop the lowest of the 4. Okay? And if you were absent on the day of a quiz and it was not excused, that will count as the lowest quiz score.
You've taken 2 quizzes so far, right?
You've taken 2 quizzes. You will have a quiz next week. That's quiz number 3. And then you'll have a quiz 2 weeks after that. That's quiz number 4. Okay. we'll cover just today's lecture. Yes.
We have 4 more weeks including today, right?
5 more including today.
Is it week 7?
4. It's week 8.
Oh, it is week 7.
Because next
7,
week.
8, 9, 10.
Not counting Veterans Day.
Okay, so you have this week,
I guess.
you have next week the quiz, and then you have another week, quiz after that, and then the final
Oh, we have
exam.
a break between our quizzes?
You have,
I thought we had to quiz after.
so. Yeah, this quarter, normally I have 12 meetings, but this quarter there's only 11, so what you are missing is normally right before the final exam I have 1 day dedicated to review. This quarter, that day will be split between a little bit of new stuff and the rest will be review, okay? So
The Tuesday before the final, right? That's the day you plan on.
Tuesday before the final will be some new stuff and review, okay? Whereas before I could just do all review on one of the days.
Will you be able to post like a list of terms we need to know?
Yeah.
Like for conceptual stuff?
No. You have your book, okay? You can flip through and there's bold-faced words. I think part of the college experience is learning how to study.
You have a study guide up.
I do have a study guide, okay? I've made this class as easy as possible. I don't feel like I need to
Did you take the test for?
give you even more stuff, okay? I feel like I've been as helpful as I can be. Okay. All right. Well then, let's get started. We're moving on into chapter 7. Chapter 7 is all about sampling inference. We have sampling, sampling distributions. This is the idea behind chapter 7, okay?
Sorry, what was that last word says?
Distributions. Sorry, but it's all squished in there. Okay, so, well, are they already selling holiday M&Ms at the store?
I'm pretty sure.
Yeah.
Probably, maybe, maybe not. Okay. All right, let's say you really like M&Ms or whatever. You buy a giant vat or bucket of M&Ms, okay? And let's say you just dump in holiday M&Ms. So you got a mix of red and green M&Ms. Okay, we're talking, who knows, 20 pounds, 30 pounds of M&Ms. There's a lot. And let's say you were obsessive and you counted every single M&M that went in, okay? And so let's say you know that there's exactly exactly 52% of the M&Ms are green and 48% are red. So let's say we know this. You stir up the vat so everything's all mixed up. And you decide to take a scoop of 100 M&Ms. Okay. So stir up the vat. Somehow we take a scoop of exactly 100 M&Ms. If we count the M&Ms that are red and the M&Ms that are green, how many green M&Ms will we have in our scoop? Will we? So someone said we will have 52 green M&Ms in our scoop. But will we have 52 green M&Ms?
No.
Okay. It's possible. We expect something around 52 green M&Ms, but can we have more than that? Yeah. Can we have less than that? Sure. So if we get 55 green M&Ms, no big deal, right? If I get 50 green M&Ms, also not a big deal. But let's say I took a scoop and I only found 10 green M&Ms. Then would that be, I guess, strange?
Yes.
Yes.
Yeah. Okay, so if we take a scoop of 100 M&Ms and find that only 10 of them are green, we would say, huh, that's weird. Okay? So we take a scoop of exactly 100 M&Ms. We count how many are green. Okay. So we expect something around, we expect to get about 52 green M&Ms. Okay. And everyone's okay with expecting to get 52 green M&Ms? Because our population bucket is exactly 52% green. So we expect to get about 52 green M&Ms. We will not necessarily get that. We will not necessarily get 52 green. Okay? We might get 55 green M&Ms. Or we can get 50 green M&Ms. But if we were to pick 100 M&Ms and only find 10 green M&Ms, then we would be surprised. What else would be surprising?
We get,
Yeah.
If you get 90 M&Ms.
Yeah, if you get 90 green M&Ms out of 100, that would also be surprising. Okay? So this already reflects what we might consider a sampling distribution in our head. Okay? We already have an idea of what amount of green M&Ms should be common, and an idea of what amount of green M&Ms should be unusual. So we get the sense that finding 50 green M&Ms or 55 green M&Ms is quite common if I scoop out 100 M&Ms from my giant bucket. But we get the sense that if we were to only get 10 green M&Ms or 90 green M&Ms, that would be unusual. Okay, so we already have an internal sense of how many of our M&Ms should be about green if we know that this giant bucket or giant, I don't know, bathtub of M&Ms is exactly 52% green. So a sampling distribution is exactly that. The sampling distribution starts off, we have a population. Okay, so population is just a large quantity that we are not going to observe directly. Okay, I told you that we knew that the population is exactly 52% green, or that the bathtub is exactly 52% green. That's going to start as serve as a starting point. And a sampling distribution goes from there, and we're going to say, what if we don't take the entire bathtub, but we only take a sample, maybe just 100 M&Ms at a time, or maybe just 200 M&Ms, or maybe 60 M&Ms at a time. What if we only just take a handful out at a time? And then if we look at this handful, about how much of my handful should be green or red. Or if we're not talking about M&Ms, maybe we're talking about people, we could say, if there's in the United States, if I take a random sample of 100 people, how many should be male and how many should be female? Or if I take a random sample of people in the United States, we could ask, how many should have black hair versus blonde hair versus brown hair, or whatever, okay? So there's a population, we're drawing samples from the population, and we're asking about how many or what percentage in my sample should have this property. Okay. So let me illustrate that. Okay, so I just want to make sure this is kind of conceptually okay. Alright, so we're talking about sampling distributions. So we have population. The population, if we're talking about a categorical variable, so for a categorical variable, something like red or green M&Ms, the population has a property called P. Has a property, and that is the proportion P. Okay. P is like our favorite letter in statistics. It shows up everywhere, and sometimes they have different meanings. So in this case, it's the proportion P. In our example, P is equal to 0.52. P represents the proportion of M&Ms that are green. So that's the population, it's got proportion P. But we aren't looking at the population directly. We're going to take out a sample. So randomly select a sample with size n. So in our example, if we're taking 100 M&Ms out at a time, our sample size n is 100. So we're randomly selecting a sample with size n equals 100. And we look at this sample. And count how many are green. Okay, let's say 54 are green. So then my sample has a proportion Okay. And this is important. The symbol for the samples proportion is p hat. Okay, so it's a p with a little cap on it. P hat. Okay. So in our case, what is p hat equal to? If 54 are green and our sample has 100 M&Ms, p hat is equal to 0.54, or 54%, but we'll use proportions, okay? So p hat is equal to 0.54. So basically x over n, 54 divided by 100. Okay. Is that okay? So we understand p is the proportion that exists in the population. But when we draw a sample, we're expecting our p hat to be close to the population proportion, but not necessarily exactly the same. It could be, if I happen to get 52 green M&Ms out of 100, then my p hat would be 52%. But if that doesn't happen, we get p hat something else. We expect our p hat to be close to p. We expect, 54% is close to 52%. We're expecting numbers that are close to 52%, like 50% or 53%, maybe 49, maybe 57%. We're expecting our p hat values to be close to p, and we don't expect p hat to be very different from p. So we are surprised if p hat is 10%. We're surprised if p hat is 90%. Let me write that down.
Alright, so x of n is just a formula we just need to know. It's p hat.
Yeah, so this would be the number that are green divided by your sample size. It's just how you get a proportion.
But we know.
So if I say 54 out of 100 are green, you need to know p hat is 54 divided by 100, 54%, okay? But if our sample size is 50, and I say 30 are green out of 50, you would say 30 divided by 50 is 60%, and that's going to be your p hat. Okay? Alright, so anyway, we expect p hat to be close to p. Alright? So let's talk about a sampling distribution, and I'm going to just jump to the result. Okay, so a lot of people were wondering what exactly can we anticipate for p hat? Should p hat, what is considered close to p and what's different from p? All of that. I'm just going to jump to the answer, and that is, so I guess statisticians or mathematicians have learned that the distribution of p hat can be modeled by the normal distribution. Okay. The normal distribution is always defined by two numbers. Do you remember what those two are? I'm giving you a description of a normal distribution. You need to know the mean and the standard deviation. Okay. So the mean of this distribution is p. Okay. So this is, we are talking about the distribution of p hat, and the mean of that distribution is p, and the standard deviation of the distribution is the square root of p times 1 minus p divided by n. Take the square root of that. Okay.
Wait, that's P 1 minus P.
Yeah, p times 1 minus p. So I didn't put a dot or a star or an x, but you should know that when you see parentheses and
No, I
letters,
didn't know if it was a 1 or not.
yeah, p times 1 minus p. Okay, so let's try this out. In our example, the population has proportion p equal to what? What percentage is green?
0.5.
Yeah, 0.52. So the proportion that's green is 0.52. And we are taking samples, taking random samples of 100 pieces. So when I take a random sample and I calculate p hat, the sample proportion, p hat comes from a normal distribution and the mean, or mu, is equal to what?
2.52.
Yeah, the mean is equal to p, which is 0.52, and the standard deviation, or sigma, is equal to the square root of 0.52 times 1 minus 0.52 over 100. So what is that?
0.0499.
Yes, so 0.52 times 0.48 divided by 100, and take the square root of that. Or 996. The letter in the parentheses? Sigma. Oh, mean, mu, standard deviation, sigma. we have a normal distribution with mean 0.52 and standard deviation 0.04996. Let's just round this off to say 0.05, okay? So the mean is 0.52 and the standard deviation is 0.05. Is that okay? Yeah? That help?
So wait, we're using E now for mean? We're not going to use the X bar?
So when we're talking about the normal distribution and the things that define the normal distribution, we use mu and sigma. If we're talking about the mean of a sample and the standard deviation of a sample, we use X bar and S. So when we're talking about distributions, we use the Greek letters mu and sigma. When we're talking about samples, we use X bar and S.
How did you get that answer? Is it getting 2.5?
Square.
Oh.
You take the square of that. Okay. All right, so I can now ask, if I take a random sample of 100 M&Ms from the giant bucket, okay, where 52% are green, what is the probability that my sample has 60% or more green M&Ms? So you have all of the pieces that you need to answer this question. You just need your normal table that's in your book or handed out to you. Are we able to get started?
Yeah.
Yes? No? You're supposed to answer this question. What is the probability that my sample has 60% or more green M&Ms? We're taking a random sample of 100 M&Ms from the giant bucket, where 52% are green. Okay, do we understand what this question is asking?
Yeah.
First of all, no. Okay, Well, that's a good starting point. So, like I said, just imagine this giant bucket, lots of M&Ms. Somehow, we've counted them all, and we know that exactly 52% of our M&Ms are green. Okay. But I'm stirring this up, and I'm taking a random sample, or I'm taking a scoop of exactly 100 M&Ms. I'm going to dump them out, and I'm going to count how many are green. Okay. But before I do that, before I dump them out and count, I want to know what's the probability that 60% or more are green. So basically I'm asking, what's the probability that I'm going to get 60 green M&Ms or more if I'm taking a random scoop of 100 out of the bucket? Does that question make sense? Okay, that's what we're asking. Do we know how to answer this? Okay, well, I told you that the p-hat, the sample proportion, comes from a normal distribution with mean 0.52. When we went through the math for standard deviation, we got the standard deviation to be 0.05. Okay? Alright, yes?
Does it matter that you say or more?
It does, because we're not looking for the probability of getting exactly 60%. We're just looking 60% or more.
You just rounded that up, right?
Yeah, I just rounded it up to 0.05.
So that would be the standard deviation. Okay, so another A. El una es como un
Okay, well let's try answering this. What would my first step be?
Look up the percentage.
0.6.
The first step, well, maybe I should draw a picture. This is the distribution p-hat. We said p-hat comes from a normal distribution. What is the mean of this normal distribution? 0.52. And I'm asking for 60% or more, right? And I want to know how often will a random scoop of 100 M&Ms turn out to be 60% or more green? We're looking at the holiday bucket. So the first thing I'm going to do here is I'm going to find a z-score. And I'm going to look up 0.6 minus the mean, which is 0.52. And I'm dividing by my standard deviation. And what is my standard deviation? 0.05. So I get my z-score to be 1.6.
Yeah.
Okay. And then what do I do?
Look it up again.
How did you get just 0.05?
How did I get 0.05? That was from over here. And I did the calculations for the standard deviation. Okay. So we did the calculations for the standard deviation over here. And we got the standard deviation to be 0.05. And so my z-score is 1.6. So I go to my z-table and I look up 1.6 and what do I see?
9452.
0.94 what?
52.
0.9452, which means how much is over here?
And then you just
Point 0.0548. So, what is the answer to this question? Yeah, 0.0548. I want to make sure we understand conceptually what's happening. Okay. So the idea again, I've got a giant bucket of M&Ms here. 52% of these M&Ms are green. I'm taking a scoop of 100 M&Ms. Okay? When I take a scoop of 100 M&Ms, I could get a bunch of green, I could get very few green. We don't know. I'm asking what's the probability that I get 60% or more green. So in a scoop of 100, that means what's the probability I'm getting 60 green M&Ms or more? How often does that happen? That happens about 5.5% of the time. 0.0548. Is that okay? Let's try another example here. I'm gonna mix this up a little bit. I'm gonna change up the problem. We still have a giant bucket where the percentage of M&Ms that are green is 52%. Okay? But I'm going to change this. I'm going to say I'm going to take a random sample, not of 100 M&Ms, but take a random sample of 50 M&Ms. Okay? So I'm taking a smaller scoop. So before I used to take a bigger scoop of 100 M&Ms, now I'm taking a smaller scoop of 50 M&Ms. And I'm going to ask what is the probability that my sample has 60% or more green M&Ms? So that changes things. So it's the same question, except I'm not taking 100 M&Ms at a time, I'm only taking 50 M&Ms. So you're going to have to redo some calculations here. The population has proportion P equal to 0.52. Our N is now 50. And know that the mean is P and the standard deviation sigma is equal to the square root of P times 1 minus P over N. Okay, so go ahead and take a moment to see if you can find the answer to this question. Very similar question, but instead of taking samples of 100 M&Ms, I'm only taking 50 at a time.
Wouldn't you just take the value that you got and put that over 100? Like make a proportion equal to each other, multiply the number you got by 50 and divide by 100. Like, you know, like an actual proportion, like making two equations equal to each other to solve for one of them. Would that work?
It would not work. You can try it out. Try doing it this way and see if you get the same answer you're not going to get. I mean, you might get something similar by coincidence, but that method will not. I encourage you to try it out. Great. Calculator?
Yeah.
Okay. All right.
That's right.
That's how you get started, exactly.
Is there an answer?
I don't know.
You just plug it into the equation.
So I got 107. For the S.
For the S, yeah, so that's not the answer.
Oh, no. I know.
What about
That's reasonable.
Just 1 month.
Yeah. I got 1.13 rather than 1.14, but
It's around.
yeah.
Did you get that?
No, it's like different calculators have different.
Did you know this one? Yeah. I was wondering how
No, you don't value it.
So I, what I did is I did P,
No,
152,
no, no.
152.
Come on, first, yeah, like
So 0.7.
you gotta divide that with everything here because of that. But I didn't divide it by this is 27. Yeah. And then once you get rid of it, now this is
No, so you get
but
one?
I 0.07, but you guys and that's standard.
Point zero seven.
You gotta get the right? So you get the standard deviation, and you divide whatever the